Hi guys, my name is Jaclyn. Today I'm talking to you about tools for evaluating process performance. So today we're going to go over key relationships, thinking with equations, Gini, which is an acronym, predicting trends, base case ratios, and graphical representations. These are going to help you communicate effectively on performance. So typical relationships you're going to see are that relate to your performance are friction loss for fluid flow, heat transfer, your kinetics, your reactor performance, separating using mass and a separating agent, and distillation. So if you want an example of key relationships and how the situation relates to the equation, the trend, and some comments on that, you can turn to page 594, and there will be a table there. It's called Typical Key Performance Relationships. And so, for example, you'll see friction loss for fluid flow, and next to that it'll give you an equation and some typical trends that you're going to see and some comments on that. So thinking with equations. When you're identifying equipment performance, when you're communicating with someone, try not to use extensive detailed equations. Use simple relationships and use trending patterns. So Gini. This is how you're going to, it's a good way to communicate on performance, and it talks about identifying your goal, identifying the equation, identifying your need, and identifying any additional information that you're going to need. So when you're predicting trends, there's typically 4 possible modifiers you're going to deal with. You're going to have a constant, something that can increase, decrease, or a value change that can be unknown. So base case ratios. This reduces the need to know actual values and some of physical properties. The ratios can relate to equipment size, but it can also relate to physical properties. And this helps establish predictions and changes in operating data. So graphical representation. When you're communicating on performance, it's really good to use graphical representation, because it's like when you're communicating with simple equations, it's easy to understand. You can help make key points to someone. An example is the Moody diagram. You can help someone learn about if you increase the friction factor, what does it do to the pipe roughness? Another example would be using, if you're communicating with someone about pressure drop in a pipe for the increasing velocity. So here's the diagram of a Moody. And so when you're communicating with someone, and you're using a Moody diagram, you want to use bold lines, and you want to bold your the area you're communicating on. The same thing with pressure velocity. If you're trying to communicate with someone and you're comparing different types of velocities and different types of pipe, sometimes it's good to have a pressure drop versus the velocity and have the different pipelines on there and showing the relationship between them. Another diagram that's good for communicating is called a TQ diagram for heat exchangers. It's useful for illustrating the behavior of a heat exchanger, and it's a visual representation of an energy balance. So here's an example when you're communicating with someone, and it helps you also kind of give a quick double-check method. You want to make sure these lines don't approach each other too quickly, but you also want to make sure they don't cross. So when you're communicating with someone on your team, it helps them double-check you very quickly, and it helps them make an easy comparison. So in summary, when you're communicating on use diagrams when you're communicating for distillation, heat transfer, and mass transfer. And when you're talking about any type of equation or relationships and performance, you want to use simple equations, and you want to use graphs so you communicate effectively.
Let's take a pause, Jaclyn.
Okay.
I'd like you to pair up with somebody and discuss Jaclyn's presentation.
Oh, that's the only ones they have in the book. So. That's a good one.
You feel free to edit your slides right now if you want. Add your Aladdin, Little Mermaid references. How awesome.
Three-person team? Or is
Probably.
Daniel communicating?
Thanks for talking about stuff.
I was talking to them.
You were? Okay.
There's a double team.
I'll take my slide. Okay.
Shared departmental honors plate. Well, I don't know where she has two honors. She has one in the honors building. One in the let's just drop it off there. So it's not good. Yeah.
Oh, you're back.
Probably just like that. That's the only thing I'm missing. I got everything else. The word. Yeah, I think I got it. Which side here? I just couldn't figure out what word.
Okay, okay.
Well, I'm creative.
Okay, cool.
You know what was a great invention? The snipping.
That really was good.
Allows me to skip anything.
Remember, like, we used to do stuff so you can right click to something.
Yeah.
Just print screen.
So you,
Whatever I want.
so you got to think about now though too, what if they hadn't made the cut, like a cut and paste on there? Because that means I couldn't, like, I cut and paste all the full time. I wouldn't have to, I'd have to retype things. So that was a great invention too.
Plagiarism to a whole new level. Now they put stupid pictures with like their names across them. That's a shame.
You know, I
You're
like,
gonna edit that.
Let's go on a change and say they're all in the light colors, right?
We're not to that place. My plagiarism.
oh, you're back. We were actually discussing,
No, actually, I got to talk to the class for a
Oh.
second.
Okay. Well, take the wand.
Take the wand.
Take the wand.